Lesson 40.b is about the law of logarithms. There are multiple laws that we're going to work out with here. We're going to work with the first three laws of logarithms. And the first thing is to remember, and I put it up there with the exclamation point, and your book puts it in bold on purpose, and that is logarithms are exponents. Exponents are logarithms. You're counting the exponents. That's what all a logarithm is. It's a way of keeping up with the exponents. In the same way that you would work with scientific notation for big numbers, exponents can be worked with logarithms. That's the only way that it works. Now, the first thing is adding logs is the same as multiplying bases. And let's look at the example here that we have. We all agree that if I said 10 squared times 10 cubed, and if I didn't work those out, I just left them like that without saying, well, 10 squared is 100 and 10 cubed is 1,000, but I just worked with it and I multiplied them together, I would then say, if I multiply their bases, I add their exponents. Now, if I stop right there and I think about it, logarithms are exponents. That means that if I'm multiplying their bases, I'm doing what? Adding their exponents. Keep that in the back of your mind here as we go through this. So this becomes 10 to the fifth. If I wrote this same idea by taking the logarithm of both sides, what I would be doing, if I took the logarithm of this side, I'd say the logarithm of base 10, 10 squared, 10 cubed. If I did the same thing right here and I said log of 10 squared plus log 10 cubed. Well, what does that mean? Well, that'd be the same thing. 10 squared is 100 and 10 cubed is 1,000. So really what I'm saying is this would be 2, this is 3, and that's equal to 5. Keep in mind, what you're doing here is you're saying when I'm multiplying bases, I'm adding exponents. And since logarithms are exponents, when I'm adding logarithms, I am multiplying bases. So it's just the opposite, right? So let's look at the example what the rule is. The log with the base of b of m times n is the same thing as the log base b m plus the log of b n. So in other words, because I'm saying this number and this number, right? Notice what I'm doing here. I'm saying I'm adding those because they're logarithms, and logarithms are exponents. So let's look at I'll extrapolate that to our second step here, and that is if I remember that since logarithms are exponents, when I divide bases, what do I do with exponents? I subtract them. So I'm going to look at the same thing and say that if I'm doing that with the same rule, the subtraction of logarithms is the same as division. And I wrote this backwards up here on purpose so that you can keep in mind that subtracting is division. Division is subtraction. And that's the reason why it works out that way. Once again, logarithms are exponents. If you can keep that in your head, you're going to treat logarithms like you do exponents. You won't have a problem with these two rules. Let's look at example 40.2, and I skipped over 40.1 if you want to read through that on your own. But 40.2 is going to have an example from log base 4 x plus 6 minus log base 4 of x minus 1. And they said that equals log base 4 of 5. Now, because I can apply the same rule, remember that logarithms are exponents, and remember in multiplication, the order doesn't make a difference, but in subtraction and division, because they go hand in hand, the order does make a difference. So this negative here is telling me it's x plus 6 divided by x minus 1. Now I can combine those into one log base 4 only because they have the same base. Just in the same way, if I were to say, and this is just an example, if I said a to the 6th times b to the 5th, that I can't add those exponents because they don't have like bases. I couldn't subtract these two logs if they didn't have a like base. But the book was really nice to us on this example problem and gave us same bases, which means I can subtract them. If I'm subtraction of exponents, that means that's division of bases, right? And so I'm going to rewrite this as x plus 6 over x minus 1. That still equals the log base 4 of 5. Well, if the log of 4 equals the log of 4, then that means that whatever the log of 4 is on this side here has to equal whatever the log of 4 is on this side here, and therefore I could say x plus 6 over x minus 1 is equal to 5 over 1. Now, take a minute and look at what we did there. We've been able to say, well, if the log of one side equals the log of the other, I can get rid of those logs. Now, at this point, I cross-multiplied it. I said 5 times x minus 1 and x plus 6 times 1, because there was 1 here. That leaves me an x plus 6 here. And I multiplied the 5. Remember that I do have to distribute that into both terms, and that gave me 5x minus 5. Once I did that, I started collecting my like terms. Subtract x from both sides, giving me a 4x. Adding a 5 to both sides, giving me 11. At this point, I have 4x equals 11, a quick algebraic division there by 4, and I end up with x equals 11 over 4. And that is the answer for this x. 11 over 4 and 11 over 4 is going to work out to dividing that would equal to 5. And that works out perfectly for our example. The third rule here, and feel free to stop this if you need to and rewatch that. The third rule is coefficients can be exponents, and exponents can be coefficients. Now, what I'm going to do is I'm going to remember this rule, and that is that if I take a number from up here, this number out here can become a coefficient. So this n can jump out to here. So notice that I put that in, and I apologize for one of them being capitalized and one being lowercase. There we go. Now we have the same. And I can put that in out to the front, back and forth. And it's because this is an equal sign, it can go either way for us. Think of logarithms a lot of times like a game where if you can just get it to be the log of something equals a log of something, like I did this, where the two logs were there, I can get rid of those logs. I'm going to do the same idea on this one here, and I'm going to try to look at 40.3, and I'm going to go ahead and say, here it is, 3 log base b x equals log base b of 8. I can't cancel them because I have a 3 out front. If I didn't have that 3, it would be very easy. I would be already at this step right here where I just dropped the logs on the previous example. But because I'm not, I'm going to go ahead and take that 3 and make this an exponential form. I'm going to put it as an exponent to the x. So now I have log base b, x cubed, equals log base b to the 8th power, or base b to the 8th. Now what I'm going to do is I'm going to look at that and say, well, now I have log base b equals log base b. It doesn't matter what the base was as long as they're the same. I can cancel the two logs and I end up with x cubed equals 8. Well, if x cubed equals 8, I can say what times itself 3 times equals 8? Well, 2 does. And I'm done. Well, I can work with this the same thing. Look at example 40.4. I've got log base 12. That's not a fun one. Base 12 to the x equals 2/3 log 12, 64. I can't cancel my log 12s because I have a 2/3 in the way. So I move that 2/3 to an exponent of 64. Now, I went ahead and did one extra step in here. The book does this step, drops the logs, and ends up with x equals 64 to the 2/3. But I went ahead and rewrote this because 2/3 in our mind as an exponent doesn't always work out well. I could break this and say 64 to the 1/3 power squared. Because 2 times 1, remember the power exponent rule says that I could pull this 2 back in here and make this a 2/3, so it is reversible. I pulled the 2 out here on the outside because I know what the 1/3 power of 64 is. What is times itself 3 times to get to 64, and that's 4. 4 squared is 16. I could have rewritten this the other way and said 64 squared, and then found the third root of whatever 64 squared is. That didn't look as exciting to me, so I went ahead and did this one because I could do this one in my head. But if you need to break this up to figure that out, that's fine, and it does work out nicely. Of course, your calculator does work with exponentials. If you need to, use the raised to sign. Make sure you're using your parentheses when you do so. So this is the 3 rules of logarithms. You'll want to memorize these rules. The next number of homework assignments in this book will have quite a few of these where they work out simply as long as you remember addition is multiplication, subtraction is division, and the power can become a coefficient and vice versa. So those are just logarithms in a nutshell. Keep these in mind that you can always look back at these rules as you're going through your homework. They're not terrible, but you do have to recognize a couple of things like, 64 can be broken up, or the fact that 2 cubed is 8 on these.